Jurnal Sinta teh yang dijekan we emang susah. Dia juga kayaknya menjaga ini.
Jurnal Sinta yang mana, Pak?
Ya, sekarang apa ini bocor.
Cok aja. Saya matikan Pak yang nyalakan.
Ya.
Enggak apa-apa bocor ini ya, mic-nya. Iya. Jurnal Sinta emang susah gitu. Karena mereka juga pada menjaga endogennya, tak?
Iya. Padahal saya mah ya kita kirim keluar aja, orang luar juga perlu kan?
Iya. Jadi nggak ada pilihan. Jadi kecuali kan bersama dengan WNI juga dibahas gitu.
Iya. Iya, makanya kita ada presentasinya kan?
Iya. Sudah tidak mungkin. Abin harapan Mas ya. Ya Allah.
Oh,
Udah. Tapi kita cari awas atau nanti abu kan berarti.
Ya, udah sama.
Halo, Assalamualaikum. Nak buka video?
Assalamualaikum, Datuk.
Datuk belum ada lagi.
Sampai dengan Datuk ni. Apa kabar? Apa kabar?
Baik.
Sihat. Alhamdulillah.
Dr. Seri. Sudah siap ya?
How's you, Dr. Abu?
Alhamdulillah. So you are already co-host now.
Come again?
You are already co-host. Your account.
What is that, Dr. Abu?
You are co-host already.
Co-host. Yes. All right. Thank you so much for that. Thank
Yeah.
you. Thank you. All right.
So we are waiting. We are waiting for the participants to come.
All right. Okay. So meaning that we have about another
30 minutes. 20.
20 minutes. Okay.
Yeah.
All right. Okay. Sure.
30 minutes.
So later I will alert my TNCAA. All right.
Okay.
Okay. Thank you.
Thank you.
Okay.
Okay. Dr. Abu, just to clarify,
Yeah.
this salutation will be Professor M. Solihuddin, Rector of Universitas Pendidikan Indonesia.
Yeah. But
Professor?
unfortunately, he need to be in Jakarta, so he'll be represented by Professor Didi Sukyadi.
Oh, okay. So for that, I take up.
Vice Rector.
Okay, Vice Rector. So I take up for this,
Yeah.
All right, okay. So Professor Didi Sukyadi, Vice Rector for Education and Student Affairs.
Yeah.
Professor Agus Wahayu, Vice Rector for Finance and Administration Affairs.
Yeah.
Professor Bunyamin Mahtuh, Vice Rector for Organization, Planning and Information System.
Yeah.
Professor Adang Suherman, Vice Rector for Research, International Partnership and Business,
Yeah.
Professor Tatang Herman, Dean, Faculty of Science and Maths Education,
Yeah.
and Dr. Iwa Katiwa, Dean for Faculty of Technology and Vocational Education, all deans, directors, vice deans, heads of departments, lecturers, and students.
Yeah.
All right, okay then. So for Professor Rector Professor M. Solehuddin, I will take out his name, okay?
Yeah. Okay.
All right, okay, thank you.
Welcome.
Dr. Abu,
Yes, Dr. Seri.
okay. Can we test on the slide, Doctor?
Yes, please.
So we are trying to share on the slide.
Yeah.
So is it okay? Everyone can see the slide?
Yes, good.
All right, okay.
Oh,
Oh, I want to test on the video because we have
Yes.
one of it is
Can you
video.
test the slideshow? Oh, good. Slideshow, good.
Okay.
Yeah, good.
Okay, try on the okay. All
You see
right.
the video?
Yes,
Dr.
video good, but no audio yet.
No, the video have no audio.
Oh, okay, good.
Without audio, huh?
Okay.
All right, okay. So can you see this video?
Yes.
All right, okay. Good. So we have another one.
Another one kat belakang.
Orang udah kirim ke dirinya sendiri.
Iya.
Susah.
How about this video, Dr. Abu?
Good. Works.
Okay. All right. You can see the
video
bullet.
also have no audio.
Yeah. The bullet's good.
All right. Okay. All right. We are done.
Okay.
Thank you.
Thank you.
Okay, apa saya di sini?
Okay. Dr. Abu.
Yes.
Okay. Are you ready for us to call
No,
upon?
not yet. We are still waiting
Not
for
yet,
the participants. Yeah, maybe after 5 minutes.
Okay. All right.
Okay.
Okay, doctor. Okay, bye.
Okay.
Yes, Dr. Abu.
No, sorry.
Yeah.
We're still waiting. Okay.
Just now you mentioned about the dean. The dean is Dr.
Kuntadi.
Kuntadi Katiwa. Okay.
Yeah.
Okay. So make the amendment, right? Okay.
Okay. Thank you.
Okay, doctor.
Aduh, mau ke kantor. Udah kan?
Nah, udah.
Oke. Masuk.
Dr. Abu, Dr. Abu.
Yes, if we are
Okay.
ready, we'll let you know, okay, Doctor?
Okay, so we are waiting for your cue. So
Yes. I will
so
let you know when it's when we are ready, okay?
so you want to start now?
No, not yet. We're still waiting
Not
for
yet.
maybe another 4
All
minutes,
right.
yeah?
Okay. Can you give us the cue?
Yes,
After this?
I will text you when we are
All right.
ready.
All right. Okay. Thanks, Doctor.
Thank you.
This is Universitas Pendidikan Indonesia. Universitas Pendidikan Indonesia was initially established in 20th of October 1954 in Bandung City as Teachers Education College. The institution was integrated as a part of Pajajaran University, then amended into Institute of Teacher Education and Educational Sciences, or IKIP, and finally re-established as Universitas Pendidikan Indonesia, or UPI. The Bumi Siliwangi building, formerly known as Villa Isola, is the university's main building as well as its icon. Villa Isola, an Art Deco building that currently serves as the Rectorate building, is now inaugurated as one of the nation's cultural heritage buildings. UPI's primary mission is to become a leading and outstanding university. Thereby, UPI is committed to promote academic excellence and nurture innovation and scholarly development in order to be a leading pioneer in the field of education. By having scientific, educative, and religious as its motto, UPI strives to balance the three concepts, all in one harmony. Universitas Pendidikan Indonesia is made up of 8 faculties: Faculty of Educational Sciences, Faculty of Social Science Education, Faculty of Language and Literature Education, Faculty of Mathematics and Science Education, Faculty of Technology and Vocational Education, Faculty of Sports and Health Science Education, Faculty of Economics and Business Education, Faculty of Art and Design Education, and UPI also offers postgraduate programs at the School of Postgraduate, including various research opportunities and civic services at the Center of Research and Community Services. Additionally, UPI also offers non-educational courses as a mandate extension of the government to nurture future graduates of non-educational programs. UPI, in its academic implementation, is committed to applied cross-fertilization approach between educational and non-educational programs to mutually strengthen both of the areas. A part of the main campus in Bandung, UPI is strengthened by 6 branch campuses, which located in several locations. UPI Bumi Siliwangi, UPI Cibiru, UPI Tasikmalaya, UPI Purwakarta, UPI Sumedang, and UPI Serang. In fostering student activities, UPI optimizes the empowerment of Student Activity Unit, namely UKM, or Unit Kegiatan Mahasiswa, and the engagement of students in various activities related to their talents, interests, and intellectual. Thus, it is not surprising if UPI students got so many achievements at the national and international level. As the center of the science and education practices development, UPI also has a laboratory schools range from early childhood education, to high school level located at the main campus and the branch campuses. In supporting the national education preservation and fostering a brighter future of education, UPI built the Museum of National Education, expected to be sources of learning, research, educated, leisure for the public, particularly for students on all levels. From the dazzling land of Bumi Siliwangi, welcome to Universitas Pendidikan Indonesia, the leading and outstanding university.
Welcome to Universitas Pendidikan Indonesia.
This is Universitas Pendidikan Indonesia. Universitas Pendidikan Indonesia was initially established in 20th of October 1954 in Bandung City as Teachers Education College. The institution was integrated as a part of Pajajaran University, then amended into Institute of Teacher Education and Educational Sciences, or IKIP, and finally re-established as Universitas Pendidikan Indonesia, or UPI. The Bumi Siliwangi building, formerly known as Villa Isola, is the university's main building as well as its icon. Villa Isola, an Art Deco building that currently serves as the rectorate building, is now inaugurated as one of the nation's cultural heritage buildings. UPI's primary mission is to become a leading and outstanding university. Thereby, UPI is committed to promote academic excellence and nurture innovation and scholarly development in order to be a leading pioneer in the field of education. By having scientific, educative, and religious as its motto, UPI strives to balance the three concepts all in one harmony. Universitas Pendidikan Indonesia is made up of 8 faculties: Faculty of Educational Sciences, Faculty of Social Science Education, Faculty of Language and Literature Education, Faculty of Mathematics and Science Education, Faculty of Technology and Vocational Education, Faculty of Sports and Health Science Education, Faculty of Economics and Business Education, Faculty of Art and Design Education, and UPI also offers postgraduate programs at the School of Postgraduate, including various research opportunities and civic services at the Center of Research and Community Services. Additionally, UPI also offers non-educational courses as a mandate extension of the government to nurture future graduates of non-educational programs. UPI, in its academic implementation, is committed to apply cross-fertilization approach between educational and non-educational programs to mutually strengthen both of the areas. A part of the main campus in Bandung, UPI is strengthened by 6 branch campuses, which located in several locations. UPI Bumi Siliwangi, UPI Cibiru, UPI Tasikmalaya, UPI Purwakarta, UPI Sumedang, and UPI Serang. In fostering student activities, UPI optimizes the empowerment of Student Activity Unit, namely UKM, or Unit Kegiatan Mahasiswa, and the engagement of students in various activities related to their talents, interests, and intellectual. Thus, it is not surprising if UPI students got so many achievements at the national and international level. As the center of the science and education practices development, UPI also has a laboratory schools ranged from early childhood education to high school level located at the main campus and the branch campuses. In supporting the national education preservation and fostering a brighter future of education, UPI built the Museum of National Education, expected to be sources of learning, research, educative, leisure for the public, particularly for students on all levels. From the dazzling land of Bumi Siliwangi, welcome to Universitas Pendidikan Indonesia, the leading and outstanding university.
Welcome to Universitas Pendidikan Indonesia.
This is Universitas Pendidikan Indonesia. Universitas Pendidikan Indonesia was initially established in 20th of October 1954 in Bandung City as Teachers Education College. The institution was integrated as a part of Pajajaran University, then amended into Institute of Teacher Education and Educational Sciences, or IKIP, and finally re-established as Universitas Pendidikan Indonesia, or UPI. The Bumi Siliwangi building, formerly known as Villa Isola, is the university's main building as well as its icon. Villa Isola, an Art Deco building that currently serves as the rectorate building, is now inaugurated as one of the nation's cultural heritage buildings. UPI's primary mission is to become a leading and outstanding university. Thereby, UPI is committed to promote academic excellence and nurture innovation and scholarly development in order to be a leading pioneer in the field of education. By having scientific, educative, and religious as its motto, UPI strives to balance the three concepts all in one harmony. Universitas Pendidikan Indonesia is made up of 8 faculties: Faculty of Educational Sciences, Faculty of Social Science Education, Faculty of Language and Literature Education, Faculty of Mathematics and Science Education, Faculty of Technology and Vocational Education, Faculty of Sports and Health Science Education, Faculty of Economics and Business Education, Faculty of Art and Design Education, and UPI also offers postgraduate programs at the School of Postgraduate, including various research opportunities and civic services at the Center of Research and Community Services. Additionally, UPI also offers non-educational courses as a mandate extension of the government to nurture future graduates of non-educational programs. UPI, in its academic implementation, is committed to apply cross-fertilization approach between educational and non-educational programs to mutually strengthen both of the areas. A part of the main campus in Bandung, UPI is strengthened by 6 branch campuses, which located in several locations. UPI Bumi Siliwangi.
Assalamualaikum and a very good morning. Hi everybody.
Assalamualaikum, Datuk.
Ya, apa
Kita
kabar?
Can we start soon?
Ya. Can we start now?
Yeah, we'll start. Our MC will start.
Okay, sure. Wait for your MC, yeah.
Okay, sir.
Intan, are you there?
Yes, sir. Did you hear my voice clearly?
Yes.
Okay, so we will begin momentarily. All right. So.
Itu nama kamu.
Yes, selamat siang, selamat petang, good afternoon. Warmest greeting from Universitas Pendidikan Indonesia. Welcome to webinar of issues and challenges in modeling and simulation for for engineering problems. I'm Intan, the master ceremony of today's agenda. Welcome to the Honorable Lieutenant General Dato Hassagia bin Abdullah, Naib Chancellor of University Pertahanan Nasional Malaysia, the Honorable Professor Dato Dr. Ahmad Mujahid bin Ahmad Zaidi.
Ada nih. Cari ya bentar.
Keluar lagi adik.
Okay.
Bukan nih nggak live.
I'm sorry for the problem. Participant, could you please make sure that you are unmuted for the meeting?
Ya teman di itu deh.
Punya di luar Indonesia punya orang.
Okay. Yes. All right. So warmest welcome for the Honorable Professor Dato Dr. Ahmad Mujahid bin Ahmad Zaidi, Deputy Naib Chancellor for Academic and International UPNM, who is also the speaker for today's webinar. The Honorable Professor Dato Dr. Nur Hasni binti Zainal Abidin, Senior Director, Deputy Vice Chancellor for Academic and International Office, UPNM. And also the Honorable Professor Didi Sukyadi, the Vice Rector for Education and Student Affairs, Professor Agus Rahayu, the Vice Rector for Finance and Administration Affairs, Professor Benjamin Maftu, the Vice Rector for Organization, Planning and Information System, and also Professor Adan Suherman, the Vice Rector for Research, International Partnership and Business, Professor Tatan Rahman, the Dean of Faculty of Science and Math Education, Dr. Iwa Katiwa, the Dean of Faculty of Technology and Vocational Education, all deans, director, vice dean, head of department, lecturers, and students. Dear all ladies and gentlemen from both Universitas Pendidikan Indonesia and University Pertahanan Nasional Malaysia, once again, welcome to webinar of issues and challenges in modeling and simulation for engineering problems. Allow me to read the agenda for today's webinar. So the first agenda is the opening, which will be delivered by our Professor Didi Sukyadi, the Vice Rector for Education and Student Affairs. Professor, we would like to invite you.
Thank you.
Yes, Professor.
Thank you, Intan Pratidina. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
The Honorable Lieutenant General Dato Hassagia bin Abdullah, Naib Chancellor, University of Pertahanan Nasional Malaysia, the Honorable Professor Dato T.S. Dr. Ahmad Mujahid bin Ahmad Zaidi, Deputy Naib Chancellor for Academic and International UPNM, who is also the speaker for today's webinar. The Honorable Professor Dato Dr. Nur Hasni binti Zainal Abidin, Senior Director, Deputy Vice Chancellor for Academic and International Office, UPNM, the Honorable Vice Rectors, Deans, Heads of Department, Lecturer, and Student, dear ladies and gentlemen from both Universitas Pendidikan Indonesia and University Pertahanan Nasional Malaysia. A very good day to all of you. On behalf of Rector of Universitas Pendidikan Indonesia, I'm honored to give an opening remark on this joint webinar between University Pertahanan Nasional Malaysia, UPNM, and Universitas Pendidikan Indonesia, UPI. I wish we could organize this seminar in a regular mode so that I could warmly welcome Professors Dato T.S. Dr. Ahmad Mujahid bin Ahmad Zaidi in person. Due to the unprecedented pandemic, however, we have to unfortunately organize this conference in a virtual mode. I do hope that this terrible pandemic will end soon so that we can resume our normal activities. We also hope that the new variants of COVID-19, the Omicron variants, will not spread both in Malaysia and in Indonesia too much. Since our MOU virtual signing conducted last August 2021, we have planned several joint activities of exchange faculty members and students, as well as joint research, conference, and publication. However, due to the pandemic, we have to rely on online activities like the webinar we are attending today. Ladies and gentlemen, in this age of mass production, producers need to conduct a series of modeling and simulation prior to real production. As a well-organized body of knowledge, modeling and simulation in engineering help to reduce costs, increase the quality of products and systems, and documents and archive lessons learned. Because the results of a simulation are only as good as the underlying models, engineers, operators, and analysts must pay particular attention to the construction to ensure that the result of the simulation are applicable to the real world. We must understand the assumption, conceptualization, and constraint of each implication and of each implication, and also implementation. Additionally, models may be updated and improved using results of actual experiments. Therefore, the title of today's talk, Issues and Challenges in Modeling and Simulation for Engineering Problems, is very timely and very important. I believe that our knowledge and skills in modeling and simulation in engineering is applicable in various fields such as mechanical engineering, science material, civil engineering, and chemical engineering. This competence is also appropriate in other areas of science such as chemistry, physics, and biology. Ladies and gentlemen, of many countries in ASEAN region, Malaysia is one of the most strategic partner countries for Indonesia. As two neighboring countries of Negeri Jiran, we share a similarity of languages, cultures, food, and tradition, which will make all exchange program of students and faculty members much easier to organize. Therefore, educational institutions in both countries, like UPI and UPNM, need to work hand in hand in strategic partnership to make the best benefit of international partnership. I'm pleased to see that our two institutions have realized the strategic partnership as we signed the Memorandum of Understanding last August. Finally, I wish you a fruitful and engaging webinar. Again, I sincerely thank the Honorable Professor Dr. T.S. Dr. Ahmad Mujahid bin Ahmad Zaidi, Deputy Naib Chancellor of University Pertahanan Malaysia, and all participants for your continued support and collaboration. We do pray that this unprecedented pandemic will go away soon, so that we look forward to warmly welcoming you all in Bandung. So I personally invite Professor Dato Ahmad Mujahid bin Ahmad Zaidi to visit Bandung, to visit our university in person, and you will be our important guest. We will bring you to some interesting places in Bandung. Maybe Ahmad, you have already heard that Malaysian tourists coming to Bandung, when going to Bandung, they had only one luggage. On returning to Bandung, they will be more than 5 luggages. Yeah, because they fill all the luggages with cheap products from Bandung. So please do come to Bandung, the city of Paris Panja, Pak Ahmad. Yeah.
Inshallah, inshallah.
With this, I declare that this webinar title, Issues and Challenges in Modeling and Simulation for Engineering problems, on behalf of our rector, Professor Solehuddin, is officially open. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih banyak.
Waalaikumsalam. Terima kasih.
Warahmatullahi wabarakatuh. Thank you very much, Professor, for opening today's webinar. So the next agenda is the main session, which is the presentation by Professor Dato Dr. Ahmad Mujahid bin Ahmad Zaidi. However, I would like to introduce to the moderator first of today's webinar, Dr. Asep Bayu Dani Nandianto. Dr. Asep Bayu Dani Nandianto is the Associate Professor in Chemistry Department, Universitas Pendidikan Indonesia, with his previous education at Institut Teknologi Bandung and Hiroshima University. Dr. Asep's research interests include chemistry and chemical engineering, aerosol science and technology, particle technology, nanostructure material science and engineering, environmental science and engineering, chemistry and chemical engineering education. Okay. Yes, seems a little bit problems. Okay. Would be okay. Yes. Okay. And also the last research interest is the chemistry and chemical engineering education. And we are also proudly introduced Dr. Asep as the 2% World Scientist 2021, awarded by Stanford University. Also winners in ASEAN Symposium for Science, Engineering, Economic, and Education 2021. Top 15 Best Scientist 2020, awarded by SINTA. And also the Best Editor-in-Chief in Indonesia for Indonesian Journal of Science and Technology 2020. There's still a lot of more achievement by Dr. Asep Bayu Nandianto, but then I would like to call and invite Dr. Asep Bayu Nandianto to please moderate today's webinar. For Dr. Asep, the screen is yours.
Thank you very much, Intan. Yeah, good afternoon, everyone. Okay, let me share just a moment. Okay, good afternoon, everyone. Okay, to this occasion, good afternoon to those of you in Indonesia and in neighboring countries like in Malaysia. Assalamualaikum warahmatullahi wabarakatuh. I would like to welcome you all to International Scholar Webinar Series hosted by Universitas Pendidikan Indonesia in Bandung, Indonesia. I am Asep Bayu Dani Nandianto from Universitas Pendidikan Indonesia. It is an honor for me as a webinar moderator to introduce to you Professor Dr. Ahmad Mujahid Ahmad Zaidi from UPNM, right? Okay, now without further ado, ladies and gentlemen, okay, please join me in welcoming Professor Dr. Ahmad Mujahid. Just a short about introduction. So Professor Dr. Ahmad Mujahid Ahmad Zaidi was born in 1980 in Perak, Malaysia, and then he received his BEng, Bachelor of Engineering with honors in Mechanical Engineering UTHM, and then completed his PhD in Mechanical Engineering, specialization in Impact and Explosion Engineering at the University of Manchester, formerly known as UMass, right? Okay, he's also now currently a professor and a deputy vice chancellor, academic and international at National Defense University of Malaysia. He is a former chief executive of International College and Automotive, a subsidiary of DRB HI-SCOM, a premier conglomerate in auto industry in Malaysia. So his talk now about on issues and challenges in modeling and simulation for engineering. Now, Professor Dr. Ahmad Mujahid Ahmad Zaidi, please, the floor is yours.
Okay, thank you. Okay, I need to share my slide now. Okay. Okay, can you guys see my slide?
Yes, yes, yes. We can
Okay,
see.
thank you.
Okay, no problem.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to everybody. Well, Honorable Professor Didi Sugyadi, Vice Rector for Education and Student Affairs, Honorable Professor Agus Rahayu, Vice Rector for Finance and Administration Affairs, Honorable Professor Bunyamin Maftus, Vice Rector for Organization, Planning and Information System, Professor Adang Suherman, Vice Rector for Research, International Partnership and Business, Professor Tatang Herman, Dean, Faculty of Science and Mathematics Education, Dr. Iwa Kuntadi, Dean, Faculty of Technology and Vocational Education, all deans, directors, vice deans, head of departments, lecturers, and students. Well, first of all, I would like to thank you to the organizer, Universitas Pendidikan Indonesia, for inviting me to this. I'm considering this as the remarkable forum or webinar to share my thought on issues and challenges in modeling and simulation for engineering problems. Well, basically, this is the outline of my presentation today. We start with the introduction and followed with the engineering predictive models, empirical predictive model, analytical predictive model, numerical simulation, and issue and challenges in engineering predictive model, and conclusion, and later the additional related reading material. So, as for the introduction, what is model? I'm not talking about this model on your left side or on your right side. I'm talking about this model. Well, model basically it is defined as a systematic description of an object or phenomenon that shares important characteristic with the object of phenomenon, which representation of an object or a system. Well, scientific models can be in material or visualized, mathematical or computational, and are often used in the construction or constructing of the scientific theories. So then, what is simulation? So simulation basically is a system. Is a simulation of a system is the operational or operation of a model, which is representation of the system. The model is amenable to manipulation, which would be impossible or too expensive or too impractical to perform on the system which it portrays. So why is modeling and simulation is so important? Well, basically here, for instance, our national car production, this is the one of the product named Privé. So this product was started with the idea. From the idea, we sketch into a design by using the computer-aided design or computer aided integrated design or so on. So from the design, we analyze this design, whether the design is suit with the environment or not. So to analyze the design, we can use any kind of simulation or software, or maybe we can use the analytical model to analyze the behavior of the design. You can use the finite element analysis, computational fluid dynamic, or mood flow or kinematics, to model the behavior of the system. From that, after we analyze, or we find any fault, we can also redo or redesign back. From then, once we analyze, we found that the system is ideal, then we produce. we produce in terms of prototype. Yeah, so we make the prototype by using the computer aided manufacturing, or CNC is computer numerical control, or RP, rapid prototyping, to produce the product or prototype. So from that prototype, then we do the validation. Okay, this is the real or physical test. Okay, why modeling and simulation is important? Because it can save a lot of money rather than you spend for the physical test, which is very, very expensive. So that's why the final analysis or design, whereby we certify with the performance, then we produce in terms of prototype, and then later we do the validation for the final design. Okay, so validation, we for validation test, we do the test rig, or we can do the field test. In the case of Proton Preve here, we do the field test, the crushing test, and others environmental tests. So then once we satisfied, then we can produce for the mass production. So why modeling and simulation? In this picture, because it helps us a lot to reduce the cost and time. Okay. In general, the engineering predictive models, or to model anything, it can be false, or it can be categorized into 3 categories. The first one is the empirical. So empirical, normally it based on the experimental data fitted. Yeah, you can perform a lot of experimental works, and then you collect the data. Okay, this experimental data, we call it as the empirical. Okay, this is, for example, in the slide here, is the experimental work. The projectile perforated the target. Yeah. So the first one is the empirical or experimental. From that, we based on the physical visualize. We get the data by observation, from the observation. Okay, another important part is in the engineering predictive models, or in the to solve these engineering problem, we are by using the analytical solution. This analytical solution basically is based on the physical law. For example, the Newton law. For instance, for the projectile or missile penetrated into the specific target, okay, we apply the Newton law, second Newton law, F equal to ma, force, the force of the projectile equals to a mass, and a mass of the projectile and the acceleration of the projectiles. Yeah. Okay. Another part is we can also model, simulate by using the numerical simulation. Basically, the numerical simulation is based on computational mechanics and material model. It is basically based on the continuum mechanics. Yeah. This is for example of the numerical simulation. Okay, you can see that the projectile penetrated perforated the target. Okay. Okay, well, I would like to start with the empirical predictive model. Okay, some of you may want to know that what is basically the empirical model. Well, it is basically a formula or mathematical equation that predict observed result, and it is derived from the experimental data, and it is not directly from the first principle. Unlike the analytical, it derived from the first principle. The empirical derived from the experimental data. If you have a lot of experimental data, then your result may be good at a certain range of data set. Well, basically, how it derived, it is based on the interpolation, okay, or it can be based on the curve fitting on the experimental data. So, well, basically, in engineering problem, two types of application are encountered. The first one is basically the trend analysis, predicting value of dependent variables, or extrapolation beyond data points, or interpolation between the data points. Another one is the hypothesis testing, whereby comparing existing mathematical model with measured data. So, well, basically, often we have data sets from experimental or observation measurement. Typically find that the data or dependent variable or output varies, okay, as the control parameter independent variable or input varies. For example, the classic gravity drop, okay, one object is drop from the top, so the location changes with the time, or pressure varies with the depth. Wind speed varies with the time, temperatures varies with the location. So method, given data, identify underlying relationship. This process known as a curve fitting process. So this is, for example, the curve fitting. So we have the given data set of n+1 at point x and y, okay, I. So identify as a function of fx, the curve that is in some or well defined, or in the sense the best fit of to the data. So we use for normally to identification of underlying relationship between modeling and prediction, or interpolation by filling in the gaps, gap between. We do the interpolation. Or extrapolation, we want to predict something outside of the range of the data. So this is the interpolation versus regression. Normally, there are two types for the empirical prediction. So distinctly different approaches, okay, depending on the quality set of data. Okay, consider the picture here in the slide here. So you can see that the extrapolate or interpolate on the graph here. Okay, so interpolate is between the point to point. So extrapolate if you want to get the point that beyond the data set. Okay, so that one is basically you can do the interpolation, but on the right side it's very hard to do the interpolation. Then you need to do the regression. So for the interpolation, normally if you have a pretty confident set of data, there's no polynomial relationship, very little or no scattered, so you can easily find the interpolation or extrapolation. So for the regression, you are not sure what are the relationship. Is very clear, it's a clear scattered, so you want to find the expression that capture the trend. So you need to minimize some measure of the error of all the points. So that's why we do the regression. So this is example, the application of empirical predictive model. Okay, in this work, we developed this semi-empirical hardness predictive model for AZ91 nano composite. Okay, this composite we produce, okay, based on the slideshow here. Okay, table 1. This is the element that we produce, the composite of AZ91 with 0.3% carbon nanotube. So basically the composite sample were prepared by milling the raw material, okay, in the planetary mill for about 20 hours, okay. Then the mixture was put into a 12 millimeter diameter die and do the uniaxial compact, yeah, at a pressure of 450 megapascal to produce this nano composite material. Okay, this is not what I would like to talk about or to share about. Yeah, basically, I would like to share about that. From this experimental data, from this experimental work, we get the data. Sorry, how to? Okay, so from the experimental work there, so we do the test for hardness test. We get the data, bunch of data. But now, how do we know that we predict the hardness behavior of this nano composite material? Okay, first we identify the transformation of hardness as described in equation 1 here. Okay, whereby the hardness, okay, hardness, HS is the maximum hardness, HI is the initial hardness, and HT is the hardness at a specific time after the initial hardness. Okay, from this equation 1 here, we get the relationship between maximum hardness and aging temperature, which is given by the Elvani and Karimi Tahiri works, yeah, in equation 2. From that, we try to get the relationship. Well, basically, the data is quite lengthy data. Here, in the slide here, I show you some of the within the extrapolation. How does this extrapolation or interpolation to get by using the curve fitting to get the relationship? Yeah. From that graph here, we get the relationship in equation 3 and equation 4. And then from that, we based on the transformation theory and the transformation of hardness given by Shah in 2007 in the equation 5 here. So from that, okay, we get we do the some of the interpolation data to get the relationships of the graph, and then we include in the equation. Okay, by substituting the equation 7, 6, 5, 4 and into equation 1, then we get this derivation of the hardness prediction. Okay, so from here, okay, we can predict the behavior. Okay, for instance, let's say in the temperature of 175 degrees of Celsius, we know that the behavior of the hardness based on the engine time hours. Yeah? So the blue one is the blue dot is the experimental data, and the yellow one or the brown one color is the semi-empirical model that we derive. So from here, we know that this prediction model is valid at the temperature 175 to 110. When we go beyond the temperature, let's say temperature 300 degrees, the prediction give very conservative as compared to the experimental data. Okay, this is some of the limitation of the empirical model. So if it beyond the set of data range, then it cannot give a better prediction or encouraging prediction. So this is another example of empirical predictive model. Yeah? So this model we develop to what we call it to get the critical impact energy of the projectile or missile that perforated the concrete target here. Okay, for instance, in this model, we need to identify the relationship, the parameter that influence the perforation analysis. Okay, in the slide here shows that there's a lot of parameter here: the density, Young modulus, shear strength, unconfined compressive strength, tensile strength, characteristic size of aggregate, average percentage amount of reinforced of each way, each phase of concrete, mass of the projectile, initial impact velocity of projectile, and diameter of the projectile. Okay, from that parameter, okay, we make it in the sense of the non-dimensional model, okay, as shown in the slide here. Okay, so when we assume that the perforation E is the perforation is equivalent to H. H is the thickness of the target. Yeah. So from that, we make the assumption that basically the perforation process consists of two stages. The first one is the penetration stage, and the second one is the cone plugging stage. Yeah? From that, we produce the empirical prediction based on fitted data here. Okay, we have several type of the empirical model here in your left side. So based on this empirical model, we compare with the experimental data that we got it from the experimental work, and then we do some comparison. The empirical data gives a very conservative predictive model here as compared to the experimental and numerical simulation. Okay, this is a good thing about this empirical. As long as it is within the data range, it can give a good or a better predictive result. Okay. Another thing is the analytical predictive model. The second one, the first one is the empirical model, and the second one is the analytical predictive model. So basically, the analytical predictive model can be classified into two categories. The first one is the classical mechanic. So classical mechanic is concerned with the set of physical laws describing the motion of bodies under the influence of a system of forces. It also widely known as the Newtonian mechanics. As long as it is under the Newton law, it can be applied it is under the classical mechanic area. So the classical mechanic also provides extremely accurate result. However, as long as the domain of study is restricted to large object and the speed involved do not approach the speed of light. Okay, the second one is the quantum mechanics. So this quantum mechanic normally in the numerical simulation also apply the quantum mechanics. When the objects or being examined are sufficiently small, in a very small particle, it becomes necessary to introduce the other major subfield of mechanics, which is we call it as the quantum mechanics, which adjusts the law of physics of microscopic object for the atomic nature of by matter, by including the wave particle duality of atom and molecules. Excuse me. Okay, so now we can, I would like to share with you guys on the application of the analytical predictive model. This is for example, analytical predictive model part 1. So, whereby this is work done by my student, Dr. Muhammad Ghazali Kamadan. So, we are producing the mathematical model development on the deformation behavior of basically the symmetric hexagonal of various angle and the square tube under the lateral loading. Okay, so this is example for the square tube. Okay, so we apply the first principle. The first principle is what? The energy equilibrium of the system, or energy balance method, we call it. The energy in is equal to energy out. whereby in this model that we developed, basically the energy input or the external energy is equivalent to the elastic strain energy stored in the structure plus the plastic energy dissipation. Yeah. So this is the model that we developed. Okay, basically we are using the energy balance method with the assumption of the rigid and perfectly plastic model. Since the elastic strain is very small, you can neglect the contribution of elastic strain. So we're focusing on the plastic deformation only. So from here we do the derivation, okay, and we do the comparison with the experimental data. You can see that the analytical or the dot one is this experimental data, and the line one is the analytical. It still give a good prediction. However, if you want to apply this analytical model, I'm suggesting you to consider this some of the safety factor element. Yeah. This is another example of analytical predictive model. Okay, for instance, okay, which one you want to use? You can use the Newton law of motion. You can also use the energy balance method. For instance, okay, on the right side is the energy balance method. So with the assumption of when projectile hit the target, so we assume the kinetic energy. Kinetic energy is equal to work. What is work? Work is the force time distance. Okay, from here, equation number 2, we derive the energy, kinetic energy, and the work, equation of work. Okay, from that, with the assumption of the impactor material is the same of the yield strength of the specimen. Okay, from that we get the derivation of the final penetration depth, which is equal to mv square divided by 2 times the yield strength and times the area of the projectile. Okay, we get the equation 5 is basically the final penetration depth. Okay, let's say you use the Newton law. I don't want to use the energy value method. I want to use the Newton law method. You still get the same derivation. You can use, as long it is under the classical mechanics, you will get the same answer. This, for instance, I use the Newton law. Newton law, F equal to ma. Okay, from this derivation, so I will get the same thing. The final penetration depth, equation 10 is equal to equation 5 by using the energy balance methods. Regardless of whatever method, you will still get the same result of prediction. Okay, as long as the method that you apply follow the classical mechanic assumption. Okay, then we compare with this experimental data with the analytical that we produce with the experimental data. Okay, the blue one line is the analytical prediction. The X dot is basically the experimental data. You can see that the prediction of form concrete plus 10% of EPS give a better prediction. So when you increase the 30% of EPS, it gives the very conventional what we call it prediction, conservative prediction as compared to the experimental data. So number 3, category 3 is the numerical simulation method. Okay, I already touched on the empirical model, and second is on the analytical model. Now is on the numerical simulation method. So basically, what the interesting about this numerical method and numerical simulation method, you can model everything. Okay, normally numerical simulation method falls, let's say, the finite element method. Okay, the finite element method is one of the numerical simulation method. Okay, the finite element method subdivide a large problem into a smaller, simpler parts, which is called the finite element. The simple equation that model these finite elements are then assembled into a larger system of equation that model the entire problem. This is what we call as the extension of metric method of the structural analysis. The second one is the finite difference method. Finite difference method replaces basically the governing differential equation and boundary condition with the corresponding algebraic finite difference equation. And the third one is the boundary element method, which is solve the governing differential equation with the integral equation over boundary of domain. Yeah. Okay. This is another new method that I think since 2003, 2004, starting from 2003, whereby people introduced the meshless approach. Yeah? So basically, in a meshless approaches, a lot of method use the some of the method quite famous is the smooth particle hydrodynamic, or they call it as the SPH. Yeah. And another thing is the element free Galilean method, EFG, and the reproducing kernel particle method, RKPM, are example of the meshless Lagrangian techniques developed for continuum problem. Well, basically, the trick of this technique basically it depend on the node. Yeah, each node depending on the neighboring node. Yeah. So this is example of the numerical simulation method. Okay. Done by my former PhD student, Dr. Muhammad Fuad Shah Koslan. Yeah, he did some numerical simulation on roll homogeneous armored plate response subject to the blast loading. Yeah, he put the armor plate here as in the this is the armor plate. Okay, and this is the spherical TNT charge. Yeah. This TNT charge will explode, and we want to study the response of this armor plate here. So, so we did some numerical simulation here. Okay, this is a symmetry plane. This is the explosive, which is the TNT charge here. Okay, this is the plate. Plate, we fit plate fixed at the edge here. Okay, and then we apply the boundary condition. So of course, before we do the test, we need to know, we need to do we need to identify to do the mesh sensitivity analysis to find the maximum to find the right numbers of element, the optimal numbers of element, rather than otherwise it will be costly. Yeah, if we put in a smaller element, then it will take a longer time to solve the problem. Yeah? So in this case here, this is the maximum displacement. Okay, this is number of element. We found out that at the number of 200,000 of element, it gives a good indicator of result. If you increase, the result will be saturated here. So the optimum of the numbers of element is around 200,000 plus here. Yeah. So from that, once we get the number of element, we need to know the right solver, solution. We are using the Lagrange solution or the ALE or arbitrary Lagrange-Eulerian method. So from here, okay, the TNT solver, we have Lagrange, ALE or SPH, small particle hydrodynamic, or Euler. Okay, from here we want to know what which one is the best coupling solution, and then we found out that the ALE give a better result in this case. Yeah. with the residual of 63 millimeter, which is close to the experimental data, and the computer time is around 96 hours, 96 hours. Okay, with the cycle about 430,000. As from here, then we do the we compare with the experimental. This is the residual deflection, and this is the distance here. We compare. The red one is the experimental data, okay, and then we compare with the numerical simulation. We found out that the numerical simulation give a better prediction. In this case, we are using the ALE, arbitrary Lagrangian and Eulerian technique. Okay, this is another example of numerical simulation method. Okay, this is the experimental. We have a shape charge here to study the penetration depth at the armor plate here. Okay, so here in this case we we are using the Autodyne hydrocode for numerical simulation of the shape charge, jet perforation and target penetration, and to validate the penetration depth obtained from the experimental result. Okay, this is for the aluminum target here. Okay, you can see that the shape charge penetrated the target. Okay, this is for the mild steel. This is for the hard dot material and RSA. If you look at the figure here, it shows that those light material cannot stand the shape charge, so it will perforate at the longer length. So when we compare the experimental and numerical simulation, and also with the analytical work, so we found out that the numerical simulation give a better performance of prediction. So another interesting about the numerical simulation, you can model basically everything. You can model everything in the world. Okay, as long as it is under the continuum mechanics, or it can be under the classical mechanic. This is, for example, okay, this is myself, okay, during my young day, and I have that time was in 2009. We submitted the undisclosed technical report to SIRIM. So we work with the this is the expert in neurosurgeon, neurosurgeon expert, Dato' Professor Jeffrey, and with his colleague here. So been given task to explore on the numerical simulation, basically on the brain, brain simulation, because the doctor wanted to know that how does the blood clot happen in the brain. Okay, so basically we explain in terms of mechanics way. This is the beauty of mechanics. So I explained to him that basically the blood clot happen when you hit the object. Let's say the head hit the object. Okay, it will create the what we call it stress wave retrieval on the object. When the refractive wave equivalent to the tensile strength of the material, then it will crack. Then the blood clot happen. So he asked me to prove by using this numerical simulation. Before that, he asked me to prove on the birth simulation, because he told me that in the hospital, sometimes the doctor had difficulty to decide, okay, whether you need to do the Caesar or you can deliver in the normal way. Okay, so I told them that okay, we also can simulate at what angle the baby can be delivered in a normal way. So we did some simulation and we compare. We get the result here. Okay, this is for the normal birth delivery. okay, at the certain angle. So when we change the angle at the 40 degrees, at the 50 degrees to 60 degrees, so the baby had difficulty to deliver in a normal mode. So then you need to do the scissor. Okay, this numerical simulation help the doctor to decide whether it can go to scissor or it can deliver via normal way or normal mode. Okay, this is the beauty of simulation. You can model everything basically. So the issue and challenges in engineering predictive model. Okay, so one of the case study here is penetration mechanics. Okay, so this is the empirical. Okay, empirical model, as I mentioned early on, it based on experimental data fitted, whereby some limitation is it is limited into a tested data range. If beyond data range, then the result will be void. Non-void. So the analytical model. So for penetration mechanic here is valid for the normal penetration incident, but not applicable to predict in the oblique incident. For instance, in this case, okay, for oblique incident, we'll have a difficulty to derive the formula or to study or to what we call it, to predict the final penetration depth location. Okay, in terms of numerical simulation, so based on the computational mechanic and material model, basically. So for instance, this is the discrete target and projectile. So conventional numerical method before penetration process, and this is during the penetration process. So the main problem in the conventional method, basically, we need to consider the failure criterion, the contact problem, mesh distortion, reliable material model, not function, and time consuming as well. This is an example of the conventional method here. Okay, you can see that the projectile, okay, penetrated and perforated the target because of due to the ricochet. Okay, you can see that how the elements severely deform. Okay, so this is basically will affect the what we call it, the prediction or the final result here. Okay. Okay. Now, okay, as I brief you about some of the issues and challenges in engineering predictive model, empirical, analytical, and numerical estimation, they all have some advantage and disadvantages. Yeah. So, a conclusion here. Okay. Which predictive model is good? Okay, in engineering predictive model, we have three models here: the empirical, analytical, and numerical simulation. As I mentioned to you early on, some of the challenges and issues and limitations. So basically, it is to me the answer is based on the problem that you encounter or you face. Okay, if it is a very simple problem, you can simply apply the analytical model, or you can apply the empirical predictive model. Okay, so if you don't have data, then you go for if it is simple problem and you don't have data, you go for analytical predictive model. If you have data, you can use the empirical model to predict the behavior. Or it is in the very complex problem and can use the numerical simulation, whereby normally numerical simulation will apply the quantum mechanics approach. Yeah. So, well, this is some of the additional related reading materials. Okay, some books and chapter in book. Okay, so some of the method here, empirical method, analytical method, and numerical simulation method that myself and my student apply for the to solve the problem. Yeah. So with that, I end my presentation today. Thank you very much. So I'm now passed back to the MC.
Thank you very much, Professor Dr. Ahmad Mujahid. It is very excellent presentation, and thank you, Professor, for your substantial and excellent presentation. Now we are going to the next session about Q&A segment. I would like to ask for the participant here for if you have a question, please raise your hand, or you can chat in the chat room. Oh, okay. Thank you. Now we have one participant, Dr. Haipan Salam. Please, if you have a question, please unmute your.
Okay. Thank you very much, Dr. Asad Bayu. Good afternoon, Professor Dato Ahmad. I am Haipan Salam from Department of Mechanical Engineering Education. I get two questions related to your presentation. This is an interesting presentation, but hopefully all of participants here can have some interest with me regarding the presentation. Okay, the first question maybe this is about some time when we want to choose the right model or simulation. We need to differentiate which one is the variable for the materials, for example, which one is the variable for the process. So how we can choose the right, for example, which one is the right materials, or which one is the right variable in process for which is influence or which is have the big contribution for these models. So how we can choose the right variable. For example, when we talk about you mentioned about the impact or in the hardness, there's also for example, in materials, what characteristic of the materials is we use in these models, and also in the variable, for example, when we talk about the mechanical properties, so we how's about the strengths, how's about the modulus, is it influence to the simulation? So this is the first one. And the second one, sometimes when we adapt to the problems, for example, in the simulation, we need to know the previous, for example, or the base equation for these models. Let's say we use like the Newtonian equation, or we use like the what we call the Bernoulli equation for this model. How we choose the right equation for the first one, and for the second one is it is it also we need to know about the current development of this research, especially in the modeling? Sometimes when I saw in the first or in the second your presentation, there is you use they use the models, the equation from the previous experiment. Is it also added to this? Can we, how we can do something like this?
Okay, thank you, Dr. Haipan. It's very a good question that posted by you. Okay, on the modeling and simulation, the first question is on the variable and process. How do we get or to know that which variable or which variable for material and process, material model? Okay, well, in the it depends. If you apply the numerical simulation, okay, okay, there's a lot of the material model. Okay, if it is, for instance, it is in ductile material. So ductile material, you know, but ductile material, you can use a lot of model. For instance, Johnson-Cook model, Cooper-Simon model. So which model is related to your or suit with your study? So it depends. If the model involved with the temperature sensitivity, for instance, maybe Johnson-Cook is suit with your simulation. Okay, you need to know the behavior of your material. If it's brittle material, for instance, you cannot apply the ductile material solution. You need to use the brittle material solution. There's a lot of brittle material solution in the numerical simulation, and well, it is subject to your the environment of your study. Depend on material properties. Okay, from your material properties, you know that the behavior of the material, and from that you know that which model will be suit with your material. And sometimes you need to modify the material model. For instance, one of my students, okay, when he applied the Johnson-Cook model, and he found out that this Johnson-Cook model cannot have some limitation, so he need to write another coding using the Fortran, okay, to what we call it adjust or modify the model. Okay, so basically it is depend on your problem. Okay, so but you need to have the material properties data. So from that you know that the behavior of your material model, and from that you will know that which model is suit with your study. In terms of processes, okay, whether I use whether Lagrange is better or LE better or smooth particle hydrodynamic better. So this one you need to do more tests. For instance, in my previous slide, I did show to you guys on the type of the solution. So I did a few with my student. We did a couple of study. We want to know which solution or processes that suit with the solution. From that, we know that which one is the optimum. Okay, in terms of the result and in terms of the time consuming. You can have a good result, but it will take a longer time. You see, so it will be inefficient. Okay, so then the next question is on the equation of the model. Okay, well, basically, if you're using the analytical solution, for instance, for this model, normally for analytical model, I will base on the first principle. Okay, it's either you can use the Newton formula or you can use the energy balance. At the end of the day, you will get the same answer, as long as you follow the right principle and you include the right boundary condition. So you will get the same answer. So I'm happy to share. I mean, if from your faculty have some problem, maybe we can have a separate discussion. Okay, we can look on the model. Okay, maybe I can advise on based on my perspective, which model is suit, or maybe I can also help to solve some problem over there. Okay, thank you, Dr. Haipan.
Okay, thank you, Professor.
Thank you very much, Dr. Haipan Salam. And then also it's very good explanation, I think. Yeah. Is there any question from others? Okay, from Dr. Hizma Muhammad Sarida. Yeah, please.
Okay, thank you. Well, to be honest, I'm not a doctor yet. I'm still a master, and I'm from logistic engineering.
Okay.
I have learned about abacus. It's related to numerical predictive, and I want to ask about how our data is validity and how much data should we take, and the error rate is low. Yes, how we get the validity of our data.
Okay, it depends in your case, since you're from the logistic department, yeah. So, well, if before you do some simulation, you need to know of course, you need to know the kind of data, eh? You need to have the set of data, and then from that set of data, then we will decide to do the prediction. Okay, this is basically in research, we have only two types of research, the qualitative and quantitative. In your case, you're talking about the quantitative research, yeah? So, okay, well, basically the set of data for the experimental work, okay, let's say you have you want to predict, let's say, the behavior of for instance,
for example, distribution of force for racking.
Sorry.
Distribution force for racking.
Okay. Equation force for racking or whatsoever. Okay. So basically, if you are using the empirical data for experimental work, so it depends on you can apply some of the statistical method. You can use the stochastic method, or you can use other method to predict the behavior of data. First and foremost, what you need to do is you need to put in the function. Let's say the input function, okay, is equivalent to the function of this parameter parameter A, B, C, and D. Okay, this is the first line of equation. You want to study the function of, let's say, A into function of B, C, D, O, F, E, F. From that, you get the relationship. Okay, A to B, A to C, A to D, A to E, and A to F. Okay, this data A, B, C, you have lot set of data. From that function, then you can further derive. This is, I'm talking about the empirical formula. Then you can further derive into the final equation based on that particular function. So I'm not so sure about the length of data, because to be honest, the more data you get will give you a better prediction. Okay, the less data will give you less accuracy in terms of result. Yeah. But we can, we can further what we call discuss about this. If you have data, because I'm the what we call it, the modeling guy here in UPNM. I love to see data, basically, because I look data is the potential things that I can produce, especially the impact journal or impact papers. Yeah. Thank you, Doctor.
Okay, thank you very much, Hizba. Yeah, Muhammad Sarida. So I would like to ask for other question from the participant, please. Please raise your hand. We are waiting for another several minutes. Perhaps some participants want to give a question. Okay, I think there is no question anymore, Professor. Okay, in the closing, so we have learned a lot from you, Professor Dr. Ahmad Mujahid, Ahmad Zaidi. Yeah, thanks for a lot of your sharing your expertise. We do hope that you can still make yourself available to attend one of our upcoming conferences here in our campus. Yeah, I hope that we hope that next year, 2022, right?
Yeah.
Yeah, perhaps we can do, I think, a symposium is better, I think, right?
Sure. We can arrange.
And then also you can send your researchers from UPNM, and then also we also from UPI also do the same, and together we can do a symposium, and then also for students also we can arrange for the like a poster session. I think the simplest way is using the poster session, and then also the main idea is we can make a publication for our students. Yeah.
Sure.
In UPI and in UPNM. Yeah. Okay. We do hope you can still do for next year. Yeah.
Inshallah.
Inshallah we can do more collaboration. Yeah. Okay. Thank you very much. And also
Okay.
now I give back to the MC, to Intan. Yeah, Intan. Let's give applause.
Yes, please have a round of applause for Professor Dato' Ahmad. Thank you very much for the very insightful materials, Professor, and the presentations. And also, ladies and gentlemen, that is our webinar session for today. We wish you have a fruitful and productive learning with, of course, our professor here. And before signing out, I think we need to have a photo session together.
Sure.
Yes, photo session together. Yes, and then therefore I invite everybody to open the camera, to turn on the cameras, and join the photo session. Yes, please. Okay, thank you very much. We're still waiting for some participants here. Yep. Please turn on your camera. Okay, thank you. Right, so I have two windows here, and this is the first windows. We'll take two poses. So the first poses, please join us. 3, 2, 1. Okay, one more, please. The brightest smile. Thank you very much. 1, 2, 3. Okay. All right, maybe for the second window, I want you to have your thumbs up. Yes, okay. In 3, 2, 1. Okay. And then one more. 3, 2, 1. All right. With the finished documentation session, I would like to thank you to join our webinar session today. And before signing off, I think Bapak Ahmad Bukhari, is there something, Bapak, for the closing remarks? Any announcement or anything else?
Okay, thank you, Intan. So yes, so thank you audience everyone. Terima kasih banyak sudah hadir. Dr. Dato' Ahmad Mujahid, thank you very much. Terima kasih, Dato'. Inshallah next year we'll have more intensive partnership between UPI and UPNM. Inshallah. Thank you very much.
Pak.
Stay safe and healthy.
Okay, you too, Pak. Okay, thank you. Thank you, guys.
Thank you very much, Bapak Ahmad Bukhari Muslim, and also Professor and all the organizing committee from Universitas Pendidikan Indonesia and also University Pertahanan Nasional Malaysia. Thank you very much. I'm Intan Pratina Dewi signing off. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor.
Thank you, Pak Haifan.
Ya, sama. Thank you. Makasih.
Boleh ingat.
Oke,
Thank you, Profesor.
Pak Haifan, Pak Ahmad Bukhari, Pak Asyik.
Atur nuhun, sadayana.
Sama-sama Pak Kadep, thank you.
Deliver.